In this video, we're going to be talking about graphing and analyzing a basic exponential equation. What we're going to start off with is f of x is equal to 2 to the x power. When we say exponential equation, we mean that the variable is in the exponent position. This is really the same thing as y is equal to 2 to the x power. To graph this, you can do the same thing that you've done for all the other functions that we've talked about this year, and that is just to make an x and a y table. I'm going to do that on the right hand side, move this up a little bit. So we've got our function here, f of x is equal to 2 to the x power. Then, if we make our chart, we've got f and f of x, or y, on the right hand side. We can pick some values for x. A nice domain of -2, -1, 0, 1, and 2 will work just fine for us for this one. So if we plug those in for x, this is 2 to the -2 power. Remember that 2 to the -2 is 1 over 2 squared, or 1 over 4. 2 to the -1 power, again substituting in -1 for x, gives us 1 over 2, or just 1/2. 2 to the 0 power, anything to the 0 power is 1. 2 to the first is just 2, and then 2 squared would be 4. On the graph on the left hand side, we can plot that. And if you take a look, the x is -2, and then the y is 1/4, and that's our coordinate right here. So we've got -2 up 1/4. Looks like that's right about there. The next one is -1, comma 1/2. Here's our input, there's our output, or x and our y. So at -1, we're going to go up 1/2. The next one would be 0, comma 1. X is 0. The f of x, or y, is 1. And then the next point is 1, comma 2. And we'll finish off with 2, 4. So 1, 2 is right here, and 2, 4. And you can see that these points are just representative points. The entire graph is going to be all of the points together. And it's actually going to form one smooth, continuous, curved line. You could even put -1/2 in here, or -1/4. So there's a lot of values in the middle here that would work for x. And if we go ahead and connect these, here's what the graph is going to look like. And it's going to get really close to the x-axis in this case, but it's not going to touch it. One thing we need to do with this graph is talk about some things with respect to the domain, the range, and then any asymptotes that this graph has. Now you can see that as x gets more negative, these values, so if we look from bottom up in this case, these values get close to but can't exactly reach 0. So if you want to draw an asymptote, you can draw your asymptote here, and we'll put that up here. So this is an asymptote at y is equal to 0. That's the equation of this line right here. And this is what the graph is going to approach, but only on one side. Actually, as x gets bigger and bigger, this side will continue to grow as well. There will be no vertical asymptote, just a horizontal asymptote. In this case, it's y is equal to 0. If we take a look at the domain are all the possible values of x. So you got to think to yourself, what could I possibly put in here for x? And the answer is, well, just about anything. You can make x as negative as you want it to be. X could be -100. That would be 1 over 2 to the 100 power, which would be super tiny, real close to 0, but it would exist. And so the domain in interval notation is -infinity to infinity. Remember, the domain refers to all the possible values of x. We have some representative values here, but there's many, many more. As a matter of fact, there's an infinite number, and anything will work for x here. If we take a look at the range, these are the outputs, or the f of x side here, and you can see that these are all positive numbers, and even if x is really negative, the output will never be negative. The graph exists from this value up, again in terms of y only for the range. So if the graph exists for every value that's bigger than 0 or greater than 0, we can write our range and interval notation as 0, infinity. So let's recap. To graph the basic function, what you can do is you can just make a table if you'd like. And we want to talk about some key things though. There is an asymptote at y is equal to 0. By the way, if the graph shifts up or down, the asymptote will shift with that. The domain is any value of x that will work, and it turns out that any real number here will work for the domain. You can pick any number and put it in for x, and you'll get an output. And the range, though, is restricted. It's not including 0, so it's an open or a parenthesis right there. But it does go to positive infinity. So that red graph here exists for all y values that are greater than 0.